Well, thank you all for coming. As I said earlier, my name is Myles Grogan. I have been in Japan for years, quite a long time. And when I came to Japan the second time, I was very involved in a placement test project, which ran on for 7 years and just expanded and got more and more. So that's where I learned about testing. Do you want to introduce yourself a little bit more? Yeah?
I'm Atsushi Mizumoto. I teach language testing at Kansai University. And I developed the web application, which will be introduced later, which is pretty awesome. But the thing is, this is like a black box. You put in data and you get the results, and you don't know what's happening behind this program. So Myles will do all the explanation what's going on behind the scene. Okay? And I'll be just invisible and will be his assistant today. And if you have problems, technical problems, I'll be support. Thank you.
Okay, so let's get started. For me, testing is really about community. It's about working together with other people. If you're making a test with lots of unique ideas, it's not really very good. We need to communicate those ideas, why a test is good. The first part of that is names. So, what I'd like you to do, please, is make a little name tablet. Card. Yes. Okay. Now we will actually be using this later on. You need to pick one back.
Sorry.
Yeah.
Thank you.
Half is okay. Another one of my interests is call. And I found that when you're working in a computer lab, one of the first things you need to know is to be able to see when everybody understands. Okay, when everybody's finished your task. So, when you've finished your name card, please put your name card on your monitor like this. Okay. Okay. Lovely.
We have a Wi-Fi connection, so if you have your own device, you can have Wi-Fi. The password is 305094.
Okay. So I can see 3 Macintoshes. Ooh. Okay. If your computer is normally, if your day-to-day machine is a Macintosh, okay, please take your name card down. Okay. This is how I run surveys in a computer classroom, so I can see who's half. Okay, half. Okay, good. Thank you. All right. And now, can everybody take the name card down? Everybody take the name card down. I want to get you all onto the website. Okay. And the website address is https, please note the S. Okay. Myles Sensei.
Oh, that's Sensei.
Sensei, yes. Sensei. .nomio.com. GNOMIO. Okay, you can all go to that. You should get something that looks like this. Okay.
Sorry, please. 1000 say dot.
1000 SEI dot nomio. That's GNOMIO.
Okay, thank you very much.
.com. And if we scroll down, at the bottom, the very bottom, there's a course called 2015 JLTA. You've done the test, now what? Okay. I'd like you to click this link. Okay, it'll ask you to log in. Don't worry about that. Okay, please check the person next to you or behind you. Is everybody on the login page? Yep. Okay, let's check each other. Communities, yay. All good? Yes? Okay. Right. Okay. It's okay. That's fine. That's fine. Okay. And at the bottom of this page, it says, log in as a guest. So, if you click log in as a guest, you will get this page. Okay, with this at the top. Okay, news forum, books for testing. What's this course about? When you've got this page, please put your name card on your computer. Okay. That's working. Now, if the person next to you doesn't have their name card up, please help. Please help. Okay?
Yeah, at the bottom.
Okay? Good.
Yeah, at the bottom is a link. This is over here.
Okay, great.
Yeah. Yeah, it's a
Here we go.
There's no password.
Different.
Different page. Excuse me. That's okay. Yes, JLTA. Yes. You have a different advert. This is okay. Okay, I think we're good. I have left on this page my PowerPoint slides. Okay, and some of the Excel files that we will use. Okay, so even after the conference is finished, you have a little souvenir on the web and you can go through them and find my spelling mistakes. Okay, so to begin with, I want to do some introductions and tell you what we're going to do today. A large part of work on tests is preparing data. Usually, after spending a lot of time cleaning Excel files, arranging columns, and putting things through Excel, we end up with a point and maybe two numbers. After all that work. Okay. So I'm going to show you a lot of the work that goes into getting those two numbers. Okay. The hands-on thing, the Excel skills. Okay. We'll probably spend the first 40 minutes or so looking at data and cleaning data. Okay. Then we'll talk about how we share data I'm not going to get into anything complicated like SPSS. Okay, that's just way too complicated. And most classroom teachers don't have it. So I'm wanting to keep it simple. Okay. And after we've done that, we'll go through things. Some of you, I know this is beginner's workshop, but some of you are not beginners. You know who you are. Okay. We will be looking at things like item facility and item discrimination. Okay, and we'll look at 3 ways to calculate the reliability score. Okay, but we'll spend a little bit of time talking about what is this reliability score, what does it mean. And we'll finish off talking about some other ways to look at testing. We're going to be looking at classical testing theory rather than some of the more recent developments, but I will be spending probably just under an hour on information, item response theory and rash analysis. Okay, which will just be skimming the top, but I hope that will whet your appetites. Okay, right, let's kick off. Oh dear. So, this is the routine that I've talked about. Okay. Just very quickly, we will not be doing any t-tests or ANOVA. That's way too complicated. We're also not going to be talking about validity very much. That's reliability is part of it, but validity is part of it is a much broader topic. Okay. We also won't be talking specifically about mastery or achievement tests, but some of the things that we do can be applied. Okay. I think Atsushi may spend a little time talking about R at the end. SPSS, JMP. Anyone heard of JMP? Anyone used it?
I've done.
Yeah. Apparently, it's quite good.
It has its uses, yeah.
Yeah. So, but this is all the next step. Okay. We'll be using Excel. We like Excel. Okay. Write some big words. Time for your teammates. Okay. I have a collection of big testing words here. What do they mean? What do they mean? For some of you, this is a second language. Okay, so I want to make sure that everyone can talk about these easily. Okay. So in pairs or in threes, let's have a quick refresher. What do these words mean? Do the easy ones first.
Don't mean what they are.
Okay, what does it mean? What's norm reference? What's criterion? What's polytomous? 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 What does it mean?
So we should discuss. So call the question now. The way I see it, we will search and find different definitions, and then we discuss. That's what I thought. But if you know, you can.
We go to the internet and find discrete points.
Okay. The top two? Oh, my phone's great. Okay. I seem to be hearing that there's a few issues with these top words here. Discrete point and polytomous, which are kind of opposites. Kinda. Let's see. Takaki, do you have any idea what discrete point is?
Where the point where I have the student.
The cutoff point. No, good try. That's something else. We'll get to. Cutoff point will be mentioned later, so that's an important word too. Okay. Ray, can you help us with discrete point?
Possibly measuring only one thing.
Yes. One question, 1 point, or one item, 1 point. Very simple. One item, 1 point. So if I do like the TOEIC listening section, part 1, we have one question. That question is worth 1 point. Okay. And the opposite of that is polytomous, and that's more like a rating scale. Yeah, we're talking if I'm interviewing for my Aiken Ikigo. Yes, and I'll give him a grade out of 5. It might be 2, it might be 3, it might be 4, it might be 5. So the poly means many. Okay. Discrete, 1. Poly, many. It's a scale. So what we'll be dealing with today is the discrete point testing. We're not going to be looking at rating scales, that's too complicated. Okay, that's tomorrow morning. So, discrete point polytomous. Norm reference, criterion reference. How are we with that? Let's see. Yuki, can you help us with norm reference and criterion reference? No, not quite. Okay. Let's see. A few heads shaking. Taka, can you help? Difficult to explain. Okay. Well, let me have a go. Okay, on a norm reference test, I would take a population. Okay, a group of people. Might be all the students in my school. Okay, and I would test them. I'll get a model which is kind of a curve. Okay. It's not really a pass-fail, it's more like looking at how the skill is distributed. Okay. Criterion reference test is something where I want people to meet a set of criteria, a set of standards. Okay, so a lot of the testing on the CEFR, the Common European Framework, is based on criterion. Now this is a big one, unidimensional. This is quite important. Quite important. You can break it down fairly easily, but what is it? What is it? Sayo, can you maybe help with unidimensional? Have you heard this word? No idea? Okay, this is a new word? Yeah, okay. Let's see, Ryeko, have you heard of unidimensional? Okay. Okay, unidimensional. When we're looking at tests, ideally we want to be unidimensional. That is, we want to measure one thing only. One thing only. Okay. To put it simply, that might be measuring speaking skills. Not really interested in reading skills. We're testing the speaking skills only. For example, if I'm talking about people, I want to measure people's height and then measure people's weights with a different instrument. I want each test should have one measure. One measure. Okay. Reliability. What's over here? Reliability. What's reliability? Can you help us out? Let's see who can help us out. Me, can you help us out? What's reliability?
I say it's just correct. Can be believed.
Can be believed?
Correct.
Yeah, a bit more. It's close. It's close. It's close. Let's see. Akiko, can you help with reliability?
Have a test is how much we can trust the test. I mean, well, if it's something like that everyone project is a test. It's
Okay, right.
oh, sorry.
It's nearly there. Trust is a part of it. If I had a problem with my kitchen, with my scales this week. I got on my scales, it said 65 kilograms. I got off my scales. I was like, no, that's not right. I went back on my scales, it said 69! With a difference of 5 seconds. That's not reliable. That's not what my scales are broken. I've broken my scales. But reliability is getting close to the same score every time we use the measure. Okay. Close enough. If we're measuring the height of mountains, and if we're measuring the height of people, it's still meters and centimeters, but we'll have a different level of error that's acceptable. Okay. The last one, validity. Validity. Nico, can you help us out?
Is it something like the test is measuring what they intend to measure?
Right. Yes. Pretty much. Yes. Yeah. There's a lot of debate about validity in testing, and the reliability is a big part of what helps to prop up that measure. Okay. More about that later on. Okay. Now here are some non-testy words that we'll be using, and these are a bit easier. Sorry. The mean, the arithmetic mean. Okay. I'm not going to ask this one, I'm just going to go straight on and tell you. That's the average. That's the average. Okay. The variance. The variance is how much difference there is on either side of that measure. And standard deviation is, well, it's a kind of variance, but it's a measure with certain properties that we'll see in a little while. Very, very useful. Okay, it's a way of dividing people up in those groups, away from the mean. Okay. We're going to talk a bit about getting data first. A lot of you filled in the questionnaire about the course, and I see lots of people do classroom testing. Getting data from classroom tests can be really hard, because usually you mark tests and you're just left with a number at the end, and you can't really see which items have worked and how they've worked. We're going to show you a way around that later on, but that can really be a nightmare for trying to prove reliability in different kinds of measures. Now, we can use computers, but how many of you have a lab like this one in your classroom? Okay. Computers are really good because if we do a quiz on a computer or a test on a computer, we get statistics like this. This is from Moodle. This is from the quiz module on Moodle. It does a lot of the number crunching for you. It tells you averages, it tells you variance, standard deviation. Okay. There are some alternatives. This is a scanner. This is a scanner. Okay, and with a scanner we can take bubble sheets and we can scan them and get data very quickly. That's getting much better, much faster, and most of all much cheaper. And the website, there's a link to a free project. You can probably use your printer scanner to scan your classroom tests. Photocopiers. Lots of the new photocopiers have a facility to scan bubble sheets. Not just bubble sheets, articles or essays, all kinds of things. Okay, that will help you store data electronically. And my personal favorite, the cell phone. The cell phone. Okay. If I could have about 5 people with pencils. Okay. What I've got here is an example of a scan sheet. I'll pass more of these around. if people could just maybe fill in some of these. The first 5 items. First 5 items. Random is okay. Anything's okay.
Has to be pencil?
Actually, pen is okay. But usually for classroom tests, the erasers come out. Yeah. The first 5, any is okay. So I've got 2 pieces of software that I've been using. One is called ZipGrade, one is called QuickKey. These are available to people like you and me. We can just download these. Yeah, if I can get about the first 5 questions, anything maybe, I don't know, A, C, D, B, E or something. Anything's okay. And now, with my cell phone, I can start my scanner. Okay, it's got a whole very easy interface for me to upload students in there. Quizzes I can grade. Sorry?
Is this free?
This is not, they usually have like 30 free, but I think I'm paying 700 yen for a year's worth of this, which is, there are more expensive versions of it that will let you work as a like a gakubu or a faculty or a school. Okay, and what I can do with these is I can go to look at a quiz, and I've got the quiz colloquium here, and I can scan papers. That's 1, 2, 3, 4, last one. 5. Can grade a class of 30 students in about 90 seconds. Okay. This is really useful for long items. So if you're doing things like, we've got some vocabulary people here, like the vocabulary size test or a levels test, you can just go through and get your answers very, very quickly. I can review each student here. Okay, and I can see John Kappa. John didn't answer any questions, but maybe he was just faint. Maybe I need to review his paper. That is his answers. Actually, he wrote C, B, C, B, A. So I can, if someone's written something very faintly in pencil and maybe it hasn't come through, I can check it straight away on the spot. And then I can go back and I can get an item analysis. Items 1, 2, and 3 are really hard. No one's getting them right. Item 4 is the easiest item. Item 5, one person got that. Okay, so we can get basic data from things like this very, very quickly. And it saves a lot of time. If I want to do more complicated analysis, if I do want to use SPSS, okay, I can then go back and I can maybe send the papers. I think that's up here. Oh no, that's not right. Okay, I can send quizzes, class results very, very easily from here. Okay, so that's a really basic form of checking that your answers are okay. Okay. These devices have been getting very popular since 2014. In 2014, 3 big companies came on the market to deal with these. Google Play has launched some more recently. So if you look on some kind of bubble sheet grading application, you'll find things. And this is going to change very quickly. this is going to change very quickly. Couple of hints. When you're grading, don't use an iPad. You'll get a sore wrist. This is heavy. Okay. But if you're reviewing papers, this is quite handy. If you've got a big test, the size of the screen really helps. Okay, so it's better to have both. All right. Right. When I first started doing tests, I was told, make a 50-item test. And I said, no, I want to make 70 items. And they said, no, 50. I said, why? We've got 50 answers on the bubble sheet. That's not the reason to use 50 items. Okay? Don't be constrained by your item sheets. We've got 50 items here. If I have 100 items, I can use 2 sheets, different colors. There are easy ways around things like this. Okay? Okay, now we're going to move on to removing and cleaning data. This is the sort of the getting the data. Now, let's all go to the websites. Okay. I really hope this works. Okay, first thing I want you to do on the website. You have a navigation pane at the site. Does everyone have this navigation pane? Yes? Check your neighbor. Does your neighbor have the navigation pane? Yes? Okay. Okay. So, if your page says getting data at the top, please take your name card down. Okay. Right. Now, if we go to the bottom of this, we go to the bottom of the page, there's a link to a file which says workshop cleaning. Workshop cleaning. Okay. Workshop cleaning, right? It's at the very top of the, underneath the text. Okay, and click. Oh, and it says, what would you like? Let's open it with Microsoft Excel. Okay, when you have this page, please put your name card back up. When you get this page, name card back up. If you've got this page, please look around and help other people. Okay, so we've got this simple test thing. Okay, and this is too big. I'll make this smaller. No, it's not aiming. Okay. Blank spaces. Alright. So when I first did my workshop, my work on testing, I got handed a sheet like this with 1,700 names on it and 50 items for each one. So there are little things you need to know about this. The first thing that really, really freaked me out was that I had 1, 2, 3, 4, 5, 6, 7 down here, and up here it said 1, 2, 3, 4, 5, 6, 7, 8, 9 as well. I didn't have letters, I had numbers here. Okay? This is called R1, C1 formatting, and if you look down at the bottom, you can see this is taken from our Windows system. If this is unchecked, you'll get, these will change to numbers. Okay, these will change to numbers. Don't do that. Letters is good. We like letters. Letters are good. It took me like 2 hours to find out how to change it back. Okay. But for you, it's in the file. Okay. So. Okay, you can change that into the general icon now. Hidden columns. Hidden columns. Now Mac users, you're lucky. You're lucky because hidden columns, the next two are highlighted blue. The letters are highlighted blue. But you can see up here we have F, G, H, J. And data was delivered to me with items missing. So always check the top row. Okay. If we highlight and right click, we can psychology, we can see them again. Okay, there's row I. Okay, so it's very fiddly without a mouse, so I can't demonstrate it. Okay, but highlight both columns, H and J, right click, and it's the very last one. Show again. It's all about computer literacy. That's really important. Okay. I find it useful to get my data on the top, so I just like to delete these columns usually. So I like to delete these so that my question items are all on the top. It makes it much easier to sort.
You still want a blank row too?
The blank rows, yes, that's next. I think that's the fourth bullet point down. There's a way to remove these. So, to get rid of the blank rows, we can highlight column A. Okay, and press, I think, is it function F4? Oh, no, whoops, not that button. F5. There we go. Okay. So, good. Blank cells. Elson, I'm not sure what is your operating system Turkish?
No, it's in English.
In English, okay. It's a blank spaces. Okay. If you press function F5, function F5 on a Mac. Okay, one more time.
Cancel zero.
First, highlight the row. Next, press F5, and we get this jump. Okay? Okay. And set a syntaku. Use the cell. That's great. Yes, there we are. Okay. If you are on this, if you're here, please take your name card down. We good? Okay, most people seem to be almost there, so let's press OK. And you can see, if you press OK, we can see that rows 2, 4, 6, these are highlighted. Now, all right, next step. Next step, this is a little bit of magic. Okay, if we right click and we go down to delete, yes. Go down to delete. Okay, it gives us this option. It gives us this option box here. So if we choose this one, the rows, and press OK, it all disappears. Okay? So, yay! Okay. There's a whole range of computer literacy skills here. There will be a test. Okay. So, I've written instructions on the text box so you can review all of these. Okay. I hope you never get data as messy as I got. But there are skills for getting those. Okay. One more time?
Yeah.
One more time? All right. We've got the, so from the beginning, highlight the row, press F5,
No, you select.
Yeah, everything.
セル選択 and okay, 空白セル okay, blank spaces, you press that, then we right click on a selected cell. That's an important part. Right click on a selected cell and then delete. Delete gives us a choice and we get rid of everything. I've got lots and lots of little tricks on this website, on this sheet. That is perhaps the most important. It's the most important because a lot of commercial systems give you too much data. Okay, so, for example, the full data from the full data from ZipGrade looks like this. Way too much data. We've got the mark, we've got the student's grade, we've got the primary key and how many points they got. It's too much. So just get rid of some of the data and use that to select columns or rows, and you can get rid of it very quickly. Okay. Before we move on, there's one more thing we have to decide about. Please notice row H8. Cell H8. It's empty. This happens a lot. Now it might be that the student fell asleep. It might be that they didn't know and they didn't want to guess. Okay. It might be that the card reader didn't work. Okay. If you have an empty cell, you need to decide what you're going to do. It's a good idea to go back and check. Okay. And with this system of ZipGrade, if I go into my account, I can see each class and it will show me each person's paper. So I can look at them at home, I can look at them at work, it doesn't matter. Okay. Other skills that are worth looking at, I'm going to show you. You can play around with these later on, maybe during the break. First thing, labeling. 1, 2, 3, 4, whoops. Oh, important skill, Control Z. Undoes what you did before. Control Z. If you make a mistake and delete data, whoops, Control Z. Okay. Some systems will give you different names and maybe names that are too short. I like to use 5-character names and fill in blanks like this. Okay. You can see the selected square in the bottom right. There's a little black X there. Okay, a little black X. On Mac, it's usually a square. It's not an X, it's a square. Okay. The cursor on Excel is usually a cross like this. It's usually white. If I move it over select a square or cell to the bottom part, I can click and drag. Okay, and it will rename. Item numbers. I always put I in front of my item number so I know it's an item. ST, student. This is a student. I, this is an item. You can make your own system, your own team can have its own system, but have a system. Okay? Another thing I like to do is to freeze the top row, so you know which item it is. There's only 10 items here, but if you've got 50, that's important. So, for reasons I don't understand, Windows made this complicated, or Office made this complicated. Please highlight row number 2. Highlight row number 2. Yes? Row number 2? Okay. And window waku, that's right, waku. No quote there. If we do that. Okay, we want to highlight the top row. Okay. Oops. And it again. Now, if I go down, row 1 stays on the top all the time. This is really, really useful.
So if you click on the cell, it will freeze the columns to the left and the rows above.
You can do it that way. It gets more. You can do more complicated configurations.
See, if you get like a lot of items, that's the most of the
Yeah. Yeah, you've got a whole range of options for freezing. All kinds. You can do the same thing for the students as well. All right, and last thing we need to do is get answers. We need an answer key. So get answers. Now this is a bit fiddly. Okay. One of the reasons I use I in my item names is because I'm going to have to replace A, B, C, and D. Okay, so I don't want these anywhere else in my data. Okay, so let's see, I've got item I01, item I05, and item I09. Okay, and now I can use the copy and replace. Oop, menu, it's very fiddly. Find and replace. Okay, which is, hang on, I can't see my notes here. Okay. Oh, there we go. Oh, where's it gone? Where's the find and replace on the Windows system?
Control F.
Control F.
Control F, of course it is. Thank you. Okay, Control F. Control F. And what we're going to do now is replace. On an English operating system, for the Mac, you can use Command F. Okay, and it'll be find and replace. So you need to click Control and F at the same time.
How do you check B, F, and J?
Okay. E, F, and J. When you're selecting your columns, keep the Control key down. Okay. And make sure the cursor, you can see my cursor is in the column name, B. Okay, I want to select that. It is selected, but we can't really see. You can see it's blue there. And then if I can go through F, do the same. And J. My finger is on Control all the time.
Ah, okay.
Keep my finger
I
there.
see.
Okay. Then Control F. Okay, and I can replace A with 1. Can everybody see this? If you got this, put your name card up. Name card up if you're here. Okay, let's help people who aren't. Okay. We've had about an hour. Time flies, doesn't it? Time flies when you're testing. Okay, now I was going to spend a little time on making histograms, but I really want to get to the meat, which is looking at the different items, the way the items behave, and making reliability. So we'll come back to making histograms and things later. I want to say 2 things about histograms before we take a short break. First is, if you're making diagrams to share among teachers, Google Documents is much simpler. Much simpler. To make a histogram in Excel, you have to set up an array function and yeah. So, but in Google Docs, there's one button, one click, that's it, finished. So some things like that are much simpler on Google Documents. Okay, let's take 5 minutes. If you've got questions, I can come around and help you during the break.
Yeah.
And I think we have some refreshments outside. Yeah.
Yes.
Okay.
Yeah.
Let's take 5 minutes. So we'll come back at about 10 past 2. Okay.
Okay, if you are lazy about converting data, this is easy way. As I said, this website is awesome. So in this website, it's called langtest.jp, and we have this binary data converter, okay, and you don't have to do this right now, but I'll show you. Okay, and you have this box here, and then this one for the answer key, okay, and it's like equals to.
It's a different file.
Okay.
But I think this.
Oh yeah, okay. Right. Oh no.
No, that's.
I'm
Maybe I
just
should
sure.
have the.
Okay, so you just copy and paste your data here, and then copy and paste the answer key there, down there, and then you can download the binary data. Okay, and there. So it's converted 1 or 0. If the answer is correct, then 1, and if wrong, then 0. So it's really easy. Okay? And if you're lazy about converting data, that's a shortcut.
Yeah, very useful.
What's the name of the site again?
Linetest.jp. Linetest.jp. There's a link in the website at the very top. Let's see, at the top of the course, there's books for testing. If you open this page, Line test is Down the bottom, under software and other resources. Okay. So you can see this anytime. Okay. Right. The only reason you might not convert to binary data is if you want to see how many people are choosing which wrong answer. Okay. But he has another part of his website that does that as well. So don't even worry about that too much. Okay? Okay, now just before we move on, I want to show two things. There is a file at the bottom which you don't need to open called histograms. And it shows the score. When we've got the score, we can sort it fairly easily. So we can put, oh, that's in rows. Why is that in rows? We can sort by different values, okay? Top to bottom, bottom to top. Okay, that's quite useful. We can also make histograms. Whoops. Where we can see how many people got 0, how many people got 1. Okay. As I said, Google spreadsheets will do all that for you much faster. Okay. There is one thing I wanted to mention, however, and that is something called a scalar graph. Okay, has anyone heard of a scalar graph? No? How about a Gutman curve? Has anyone heard of a Gutman line? Okay. Scalar graph basically creates that. What we can do, and there are instructions on the side here. Okay, instructions on the side. We can sort the scores, highest to lowest. Okay, and then we can sort by item, hardest to easiest, using the sort functions. Okay. There's a way on here that will show you how to sort it left to right. Okay. And then if we go to formatting, we can get every cell with a 1 to be highlighted. And you can kind of see the curve where the people who are doing well, you can see which items they're getting right and wrong. And you can see roughly the line of difficulty as it goes down. We don't have time, so I'm going to cut this part. But please take a look at that on your own time. I found this to be very useful in looking at weekly quizzes or class tests, because there's a lot of information easily available with this. Okay? Right, now, let's, on the website, let's go to item facility and discrimination.
Looking at test items.
Okay, all good?
Looking at test items. Samba, number
Okay.
3. Midigawa no Samba is no.
Is everyone found?
Yeah. Yeah.
Discrimination. Okay. Right. So, I mentioned earlier about my bathroom scales. First they said I was 65, then they said I was 69 kilos. That's not reliable. Similarly, if we're giving students an end-of-term test, then we need them, if they were to suddenly have memory loss and take it again, we would need them to get roughly the same score. There might be a few items they were guessing that they got wrong or would get right next time, but it should be close. Okay. Before I talk about reliability, there's something very important I do need to mention. Does anyone know who this is? No?
It looks
No.
like you.
There's a chap named Stevens, okay? And he described 4 different scales of measurement. Okay? So when we're talking about classroom measurement, what kind of measurement are we doing? When we're giving tests, what is it that we're measuring? What kind of thing is it? Nominal scale. A nominal scale is very easy. That's where we might divide the class into boys and girls. Nominal, name. Okay. Ordinal is in order. If we all had a race to the nearest Starbucks, and said in first, second, third, fourth, that's order. Oh, sorry. A ratio, an interval scale, is something where the units that we measure are kind of close. Not perfectly, but kind of close. Certainly within the area that we're measuring. We might get more error outside the range that we're measuring at the extremes. But usually the intervals are fairly regular. And a ratio scale is a scale where every unit is almost exactly the same, like a centimeter. A centimeter is a centimeter is a centimeter. It doesn't change. So think about our end of semester classes. Which one are we giving? Is it a nominal, an ordinal, or an interval? Interval or a ratio scale? If I give students 50 questions for their end of semester grade, is that a nominal scale, like a name, ordinal, order? Is it an interval scale of measuring units that are the same or similar size? Or is it ratio? Is it perfectly the same? Now a lot of people will tell you that in fact it's an ordinal scale. When we give students 50 questions, it's kind of a race. It's who's getting the most points. The distance between points may actually be quite different. Okay, if Atsushi and I run to Starbucks, and maybe Ito is behind us, maybe he likes coffee more. Maybe he's well in front of both of us. Okay, so we're very seldom measuring things that are exactly the same, and that's one of the biggest problems with our schools. And reliability. So, we in fact tend to be using different kinds of systems. They're all measuring roughly the same thing. In this case, they're all measuring weight, and they're all measuring English, but they may actually be slightly different. Okay. So, there's all, the way we think in classical testing theory is, we have an observed score, 70%. But that observed score is made up of 2 parts. Part 1 is the true score, the true ability. And part 2 is error, which some people call uncertainty. Okay? It might be that the room was too hot and they were sleeping. It might be that they were having a really lucky day. C was the letter for them. It might be any one of a number of things that are not related to the construct that we're measuring. Okay, so when we're looking at basic testing, we're looking for good things like normal distribution curves, okay, bell curves, this kind of thing. Okay. Now, I talked about these earlier on in standard deviations, which are wonderful things because they're very, very regular. And this really helps us talk about how reliable our test is. We can use this regular feature of a curve to our advantage. Okay, quick question in small groups. If I'm giving a placement test, okay, I've got all the first years in my school. Does it matter what kind of curve I get? A, B, C, does it matter? Which is better? Which is better? Quick check, what do you think? Placement test.
Yeah, it is.
Placement test, what do you think? Does it matter?
Yeah, it matters.
Yeah, yes, it matters. What do you think? What do you think? Hooray, boo, hooray, boo. What do you think here? Yes?
Yes.
Yes, this one? Boo, boo, hooray, boo. This one? Boo, boo. Okay. It does matter. Think about a 2-point piece of luck. You know, someone who guesses 2 points. Here, if I'm dividing into 3 classes, it's not going to make a big difference. Here, it's going to make a huge difference. Okay, here, acceptable. Acceptable. Ideally for a placement test, I'm looking for a lower curve. But we never get exact curves. This kind of curve is what we get if we're doing some criterion reference testing. If we want everybody to prove that they know something, this is the kind of thing we want. Okay, this is called a skewed curve. Okay, it's not normal, it's skewed. But most distributions are actually skewed. Positive skewness, negative skewness. And I still have to look up which is which. I've been doing this for years. Okay. With a good distribution, you get Hensachi. That's where your Hensachi scores are coming from that shape. Okay. Z scores. Z scores, which are kind of similar. Okay. And lots of other scores. Okay. This is from the Brown book. Okay, it's getting a little old now, bless it, 2005 publication. But it has been immensely helpful. It's got real step-by-step, basic, you know, what to enter in each cell in the formula. Take a look later on. Okay. So we've got a raw score of 41 if that's the average. And a standard deviation is 10 points. Then a Z score will be -1, a T score will be 40 or 50. Okay, CEEB score, which is, it's kind of like it behaves the same way as the TOEIC score does. It's got a midpoint of 500, and it's used for college entrance tests. So we can use the features of the normal distribution to get some good data. Now, the first calculation of reliability is probably the KR21. Okay? Yes.
Yeah, sorry, please. Before you go into the formula, and could you go back to the 3 curves that you showed us earlier on?
The 3
curves, bell curves, yeah. So please, could you explain why A is preferred?
I would actually prefer C.
That's right. I also prefer, but
this
but
is
why?
acceptable.
That's right.
I would say this is acceptable.
Okay.
This is not.
That's right.
This is not.
That's right.
This is too narrow.
That's right.
If I have a group of 100 students,
yeah,
and this range is very small,
20,
maybe
that's,
20,
yeah,
an error of 2 points in the observed score.
Yeah.
Lucky 2 points up puts them in a high class.
That's right.
Unlucky 2 points down puts them in a low class.
Okay.
And most of the people in the middle class are in the middle, well, they might actually have got lucky or unlucky. You might have quite a big range in that middle class. So I personally would prefer C.
Yeah, C, that's right.
Because error is less likely to be amplified.
That's
out.
right. Okay.
Is that okay?
Yeah, thank you.
And everybody else? Good? Yes?
So majority chose A.
I think A is a more traditional looking curve.
That's right.
For me, it's still a little high.
Yeah.
Okay.
Okay, thanks.
If we want to try and use the maximum number of scores, but that's into testcraft, that's into making good items that will identify people and get a good distribution. Okay, so if we get this kind of curve, we have to go back and look at our items and say, why are we getting that? And we'll get to that in a minute. Okay. First measure of reliability then is the KR21 formula. And this is a very useful formula if you only have a list of scores. Okay, if you don't know a whole lot about a group, if you give them like a paper test, you don't have Excel data, you don't have your fancy cell phone scanning system, you've given people the tests and these are the test scores they've got. Okay. Let me walk you through this formula very, very quickly. Okay. K over K minus 1, this is the number of test items. Okay. So, if I have 10 items, then this will be 10 over 9. Okay, and that's 1.11. But if I have 100 items over 99, that's much smaller. So the number of items that we have is quite an important factor. Longer tests usually provide more stable performance to check. Okay? Well, we've got the mean of the test scores. Okay, again, we're minusing it from the number of test items. Okay, so this is quite important. And over here we have the standard deviation, okay, which we saw on the bell curve. Okay. All right, just for time, I'm going to take us through an example of this, like this one. So, on the data that I gave you earlier, that we played with all the Excel, we had 10 items. 10 over 9. Okay. Now the average score was 3.77. It was a hard test. That was a hard test. And the standard deviation was 1.84 because it was quite a hard test. 10 items. Average is 3.77. Standard deviation is 1.84. Is it a good test? Is it going to give us our distribution? No, it's really not. Let's have a look. Okay, we can compare 3.77 over 10 minus 3.77 over becomes that. Okay. This may be the lowest reliability figure I have ever managed to get. It's actually a small subsection of a larger test, mostly made up of the difficult items. Okay, so this is not a real score. Okay, so we want to avoid getting scores this low. We're looking for extra space. Okay. Okay. Okay, quick group discussion question while we're getting sorted out here. What's a good reliability score? Top reliability score is 1. Never happens. Never happens. Okay? What's good? What's good? What's a good reliability score? In your pairs or in groups? That's it. Maki, what do you think? 0.8? 0.8 is good? What do you think?
0.8 is good, but maybe we have 0.7.
0.7?
Yeah.
0.7? Okay.
Well, I think it depends on the number of the items.
Yes. Yes, it does. It's one of those things that if you read the books, they never give you a straight answer. But there's a reason for that. It does. It depends on so many things. If I teach a class of 13 students. If I give 13 students a 10-item quiz, I should not be calculating reliability. That's just look at the papers. How do you feel about it? Numbers aren't going to help you there. Okay. The bigger the group, bigger the sample, okay, the higher the reliability we can get. The longer the test, the better we get. But as a rule of thumb, 1.0 never happens. Okay. 0.9 is very good. Very good. It's amazing. This is TOEIC level. Okay, this is very precise measures. We are getting some instruments that get up there. Okay, but this is really good. 0.8 is a basic target. We should all be looking to get for about 0.8. Okay. 0.7 is maybe okay. If it's a small group, then maybe that's okay. But if it's a big group, I'd be concerned. I'd be wanting to look at test items and other things. Okay. So these are the basic numbers. Let's look at how we might improve test reliability and find out which items are working and which ones aren't. So let's go and take a look at the bottom of our chapter. There's a section called item analysis. It's on part 2, I think. Part 2 or part 3? Let me have a look. Part 3, yes, part 3. Looking at test item facility. Looking at test items down here. You can click here. Item facility, item discrimination. And at the bottom is another worksheet. Item analysis. Click OK. Yet? Oh, you did good. Okay. So there are tabs at the bottom. There are tabs at the bottom. This is the kind of data we might want to take and put into the binary converter. Okay. Let's take a look at item facility. Item facility. I have 100 students here. IF and ID. Okay. I have 100 students here. The top row of this should be frozen, so you can see. Can I just check, please? Is everybody on IF and ID? IF and ID. If you're on this page, please take your name card down.
7.
Okay, we're on IF and ID. IF and ID. IF and ID. Okay? Good. Okay, thank you. Please put your name cards back up.
いやでも点数による
Now, for reasons that I don't fully know, test takers like the number 1. Test makers like the number 1. So, if we were to take the average of people's performance on a single item, the first question of a test, okay, if everybody passes that item, the average score on that item will be 1. If nobody passes, the average score will be 0. Okay? So if it's an easy item, it'll have a high score. If it's a hard item, it'll have a low score. And if we look at row 105, row 105. At the bottom, row 105, you can see we're taking the average. Okay. Computer issue. Notice this says average A. Average A, which is an average of the range in Excel, not the average of the numbers only. If you change that to average, it'll show the average of 1, because it's only counting instances of the number. We've got the range here. Okay. Now, item 1, out of 100 students, it looks like 46 got it right. So the item facility is 0.46. Item facility means item easiness. Okay? Yes.
Shouldn't that be B2 colon B101?
You're right, it should. Let's see if that, and that will make a difference too, won't it?
147.
Oh, you found my deliberate mistake. Well done. Okay. Yeah. Another thing that's worth checking is if you highlight in the function bar here, if you click on the numbers, you can see they've changed to blue, and you can see which cells are being used. Okay, so before I had it on the 100, and I can see, or Ray can see, that the bottom entry is not included. Okay, so we're taking the average for each item. Let's take the average for each item. Let's change that square, that cross to a black cross, and drag across for all 20 items. The higher the number, the more students got it right. Yes. So if we're assuming that our students are actually engaging in the test and not just writing B or whatever, then yes. Okay, so we can see that items 2 and 3 look to be a little easier. Oh, item 6, that's an easy one. Yeah, item 7. Oh, item 9. That's hard. Now we could go through and eyeball these. We could also sort from left to right if we wanted to. Okay. So a good range on a placement test. We're probably looking for items between 0.3 and 0.7. If an item is too hard, it's not helping us separate people out. And if an item's too easy, if everybody gets it, it's not very helpful. It doesn't tell us about how that student is different from another student. But there are advantages in having easy and difficult items. I was at a conference about 2 weeks ago talking about, one person was talking about computer adaptive testing. And one of the problems with computer adaptive testing is it tests people until they get the items wrong. So people leave it going, oh, I got it wrong! And that's no good. So if you can finish with an easy item on a computer adaptive test, something that we're fairly sure they can get, it makes them feel a bit better. Okay. So finding the easy items and the difficult items, that has a lot of value. Okay. Right. Now, the next part. The main goal of a placement test or a norm reference test is to divide people into groups, divide people into ability. We need to know, is it dividing? So let's divide our learners by score. Okay, let's divide our students by score. Right now, the students' scores, the students are sorted by student number. Let's try and sort them by score. Can you go to column V, please? Column V. Okay, and data. Okay, and if we click this button here, it means the people on the top got the highest score. Okay, you can get my magic stick. Can everybody see this button? Okay, so go to row V and click this button. When you've done that, please take your name card down. Okay, name card down when you're finished. When we've got this order, yes? You're okay? Lovely, lovely. Okay, so now the easiest way to find out if we're separating students by ability is to divide the students up and take the middle scoring students out. So that will highlight the difference between the low score, the high scoring and the low scoring. And that's how item discrimination works. This is the good kind of discrimination. This is discrimination in the sense of noticing. Okay. Are these items separating people? So if we go down the bottom, Control and the arrow key will take us down. Okay, and back to column A. You can see how I've laid things out. I've got 107, 108, I've got the top third. The top third scorers. Okay. I've written the columns that I want to, the sections that I want to look at. I find this is very, very helpful when dividing people. So I can copy and paste the top third anytime. Okay. I also need to check, I've got 100 students, so I want 33 as my third. Okay. You may have to make a decision. If you've got 100 doesn't divide by 3. It doesn't divide by 3. One student's going to have to be cut. You might want to put 34 in the middle. That might be doable. It may be that you've had a student who reported he wasn't feeling well. Okay, so you might want to cut that bottom scoring student out. If you've got a reason to, you can do that. Okay. So what I've done then is I've taken the item facility for that top third. So the top third, the highest scoring people, overall they've got 0.47, but the top third, they're getting it. They're getting it. Okay. The bottom third, they're not getting it. They're not getting it. Okay. So it's the same formula, but just for a shorter range. Okay. So let's fill these in. For the next 20. Okay, and that's giving you a score of item discrimination. Item discrimination, which is the score of the bottom subtracted from the score at the top. So 0.82 minus 0.15, that's 0.67. So, what this tells me is that more people in the top are getting it right than people in the bottom. By a good number. By a good number. Okay. Now you'll notice that I've got some squares that have turned orange or red. Red or turned colorblind? Red, I think. Red. Okay, so these are scores under 0.3. Under 0.3 is not so good. It's not making a big difference between the top and the bottom third. These items are not working. And when an item doesn't work, we need to go back and look at the item to find out why isn't it working. One issue we had on the placement test, for example, that I was working on, perfect tenses. They cause problems fairly equally. They cause problems fairly equally. So they didn't discriminate, they didn't separate people. Oh, there's another problem, isn't there?
It should be B69 to B101.
B69. Okay. Yes, there's a few problems here. The first problem is that the third, I said that my thirds should be B32 to B34. It's B33. Okay, so we can edit that. That's why we leave it written up there. There are often mistakes. There are often mistakes. So can you see here? B32, 34. We need to make sure these check. Okay. In the next cell, it's 32 to 33. It's up to 33. That should be 34. Okay, so this is incorrect. That should be 34. I think what happened was I was editing and deleted a line. And that will cut a line out. Okay. But that's why we keep the row numbers very clearly visible. Okay. And Ray, you said what was the other one?
99 to 101. That will give you the bottom 33 students.
Yeah, 10. Yes, it's B9. Yeah, that's deleting again. So be very careful when deleting. It can cause unexpected problems. So this is cell B101. No, sorry, 111. On your copy, it says B67 to B99. That should be B68. You can see the difference there. That's why websites are better. It says B100. It should be B101, isn't it? Yes, B101. So your maths teacher probably told you to leave the working out. Show the working out. Okay? Very important. So that when we make mistakes like this, we can find them. And then click and drag and make it right across the board. Okay. So, item discrimination. 0.3 is okay. 0.4, good. We should be aiming for 0.4. Okay? 0.8, 0.9, wonderful. Wonderful. It can happen. It can happen. There's no top level. There's no top level. If it's below 0.3, you need to look at the item and find why it's not working. Okay. The problem may not be the item, the problem may be the students. It may be something that they haven't learned yet, or so don't forget to compare students and items. The two need to go together.
So,
yes.
what about when we're making items for practice test? Practice test, not an actual test. Do we have to give serious consideration to item discrimination? For example, I make items for TOEIC preparation. Yes. So do you suggest I give much attention to item discrimination, even though it's just a practice test?
I think for a practice test, it may provide you with useful information about the performance of the class where they're struggling. If there are any particular groups that are struggling. Because if it's in a class, you'll have some idea of which students it is.
Yeah.
So it will help you in providing ideas for which groups need more support.
I'm dealing with 1,000 students.
1,000 students?
Yeah. Per semester.
Okay.
Working with over 2,000 questions or 2,000 items.
I don't really know. What do you think? I'm tempted to say for practice items, don't worry. For me, that would be a question of test specifications.
Okay.
Rather than numbers. I want to be looking at design of the items. Now you can use this to inform your test design.
Okay.
But I don't think you need to take these for practice items.
Okay.
Any comments on that?
Well, I think a lot of it's going to depend on the content. Like, for example, if you look at item, where is it? We have one that's really easy here, right? It has low discrimination. So, for example, item 6 is quite easy. And it can't have high discrimination because it's an easy item.
That's right.
And you want to have some easy items, which means that you always have some low discrimination on. In your test, if you're trying to, for example, diagnose which things students need to work on, the items with a high discrimination will give you better diagnostic information.
Okay.
But there may be other things, like for example, vocabulary may have a lower discrimination because it's easy for low students to learn difficult vocabulary.
Okay.
But grammar, things like grammar, or if you have a speaking test, things like fluency, it's nearly impossible for a low person to have good fluency. So that will discriminate very clearly. So you'll have a very high discrimination on some things. So it always comes back to context. But this is a big problem for CAT, and when they try to use computer adaptive testing to assign learning, and they have low discrimination items, and it's like, where do you assign them for learning?
So this brings the question of design.
Yeah.
So what I decided to do is that I have 24 lessons. So I put the easier ones or the easiest ones in the first lesson to encourage the student. Then gradually I make them more difficult. But I don't know if, since we have the expert here, if that is a best approach.
Well, I think as you pointed out a couple of weeks ago, if it gets gradually harder, people can lose motivation.
Okay.
So
some of them do. That's true.
Gradation.
Yeah.
Might help.
See, ETS have done a lot of work on this with computerized learning. And I think their decision was you're better to put the low discrimination items at the start of the course.
Oh, I see.
But their work was really very technical and very hard to follow.
It's context specific.
Okay. Okay.
We'll need to compress and move on. So we've still got a long way to go.
Yeah, okay.
Okay.
Okay, thank you.
I think we're probably going to end up having a break in about 10 or 15 minutes after we've done point by serial intersection. And we can talk about it during the break. Now, what we've done here is we've split the class into groups, and we've subtracted. So this is called subtractive discrimination. Okay? Subtractive discrimination. There's another way to look at item discrimination, and it's called correlational. Correlational. So you can look at how people perform on an item and how they perform on the rest of the test, okay, using the Pearson formula. Excel has a feature whereby it has two functions that do the same thing. It's Pearson or it's Correl function. They're the same thing. You get the same answer when you run it through. So what we've got here is item 1 converted to binary data. Okay. And I've used the Pearson formula. So what I'm doing is I'm running a test of this item compared with the overall score. Okay, and that overall score is over here. Again, I've ranked it. Okay. Okay, and again, if you go to cell 103, B103, you can see that I've ranked I've put the formula in there. Notice the V2 to V101 have got the little dollar signs on them. Okay. What that means is that when I click and drag, that it stays with V. Okay. When I click and drag, usually the column will change. So you can see in row C, I've got the score for row C. In row B, I've got the score for row B. Okay. But the V is always the same. Click and drag and take a look. Okay? So usually about 0.35 is good. 0.35 is good. Wherever we go in this formula, we've got V2 to V101. That's the scoring column. So the last part doesn't change. Okay? And this helps us identify which items are working well, which items are separating people well, and which items are not. So when the score is low, we need to go back and look at the item and find out what's not working. Okay. One last thing. We've talked a little bit about the number of items being very important. The very last cell, item number check. The very last workbook, item number check at the bottom. If I'm getting a low reliability score, I've got 20 items down here, number of items 20. I've got a score of 81. I'd like to get 0.85. And I can do that by lengthening my test, but how many questions do I need? Well, using this formula, it tells me 27. Okay. This formula is on the website. found in the PowerPoints. Okay, and we'll talk a little bit about how to get those reliability scores later on. Okay, and how to make tests longer and better. Okay, right. It's 15:07. Come back about 25 past. 25 past is good. Let's take a break. Looks like everybody's head is very full. Okay. Let's think about getting back. We're going to move on to section 4 in the workbook. At the bottom of your of the page right now, we've just finished page 3 or part 3. And you can see it says part 4, reliability measures and other calculations. You click this, or at the top in the navigation section, part 4, reliability measures and other calculations. Okay, and that will take us to this section. And we also have a workbook here, which is at the bottom, the reliability workbook. If you'd like to open that. You may have to click to allow yourselves to use the file. Okay, just before we move on, a couple of people have said they're a bit confused about PBI. When I started, I had great problems with PBI, mostly because lots of people called it different things. This is the Brown's testing book. In the glossary, he says PBI stands for point biserial correlation coefficient, which doesn't have an I in it at all. It's coefficient I. It's very confusing. It gets lots of names. It's much more important to focus on what it does. Okay, it's about the relationship between the score of the individual item, okay, and the score on the whole test. People who pass and people who fail. Okay, so people who fail would get a, they'd be taking away from the correlation of a high-scoring test, and people who score well would be adding to the correlation of a high-scoring test. Okay, test item. So, yeah, it is a little confusing. Item facility we talked about is also called a facility index by several people. So names do change. Names do change. Focus on what it does. Okay. Right. Making and using reliability. In classical test theory, this is really one of the most important measures. It's a very small measure because when it comes out, as I said before, it is just 2 numbers and a decimal point. But it's very powerful. It lets us look at how good our test is, okay? How reliable our test is. We're gonna look at 3 other measures of reliability. We might narrow it down to 2 because we're running out of time. We've covered KR21 briefly, that's the Kuda-Richardson 21. I'm going to introduce split half reliability, Cronbach's alpha, which is possibly the most common, and the Kuda-Richardson 20. I don't know that I've seen it. Have you seen it reported in any journals? It's not often reported. It is supposed to be more reliable, but some people were asking in the questionnaire about different measures, this is a very convenient one. Okay. Split half is a very easy way of thinking about reliability. Okay, it's also very easy to do on a spreadsheet. Can be a little bit fiddly though. So, what we do with split half reliability is we split a test. So a test of 20 items, we might divide into the odd numbers, 1, 3, 5, 7, and even numbers, 2, 4, 6, 8. And we see how well they correlate, how well they match. Okay. Now there will be some variance. You know, some people will get higher score on odd numbers. Some people will get higher scores on even numbers. It'll vary. Okay, but it should come out to being roughly equal. But there's one small problem. Do you remember when we did the KR21 formula? The number of items was a very important factor. If we split the number down the middle, we're going to end up with a less reliable, a lower reliability number. So we have to adjust for that. And there's a formula for that, which is, it's in the workbook, it's also in the PowerPoints, and it's on your website as well. Okay? So here's the split half reliability theory, reliability formula. Okay, so very briefly, this is the ultimate number we're going to get. Okay, that we've altered because we've made the test shorter, so we compensated a little bit. Okay, we have R here and here. This is the correlation between the two test halves, which we do using that Pearson formula again. Okay. N is the number of times the length is to be increased. So if we've taken two halves of a test, then we have to multiply the test by 2 to get back to the old length. Okay, so we squeeze that number back in here. Okay. Right. Let's take a look at the worksheet. Okay. So is everyone on the split half sheet? Yes? Split half, okay? Okay, good. Okay, now you can see in row W, I've got the scores for the odd numbered items. And in row X, I've got the scores for the even numbered items. To do this, you just use the sum, and you can add them all together. You could actually use the plus sign. It's a little bit faster. If you've got a long list and you're selecting, it's a little bit faster to do it this way. Okay. I put the total score there just for my own information. We don't actually need it for this. Okay. I've taken the mean and the SD and the correlation, also just for information. I do need the mean though. So, the split half is N times R So, R is the correlation, which I've listed at the bottom here. So that's Pearson. Maybe we can go up a little bit and see this. I've got the correlation of these two numbers, these two sets of numbers. These are the scores for odd and even correlation. Okay? Yep. Okay. So I think, can you see row W and X and the text box and formula? Can you see all of that on your screens? I think my screen is a little small because it's on the projector. Okay, but in this case, N is the number of times you need to increase it, which is 2, times R, which is the correlation, which was 0.73. Okay, all of that is over N minus 1, so that's 2 times minus 1 times 0.73, which is the correlation, plus 1. Okay. The bottom line of that equation comes from 1.73, and the top line is 1.45, giving us 0.84 reliability. Is that good?
It's all right.
I'd be happy with that for a general test. Yeah, that's pretty good. I'm happy with that. Okay, easy enough? Oh, easy enough? It's a very easy idea. Okay, most of the legwork, most of the hard work with this is remembering what each of the numbers means in that formula. Okay, which is why we try and write them out in different places. You see, I wrote the correlation. There was a box for the correlation. The N is 2. Okay, we've got that written in the formula as well. I think that was all we needed for that one. So this was the easy one. Okay, Cronbach alpha. Cronbach alpha. Cronbach alpha is a very useful reliability number. It's useful because it's very diverse. We can actually change the formula and use it for polytomous items. Polytomous? Polytomous? Polytomous, yes. Remember what that means? Like speaking scales. Scales. More than 1 point. Okay? We can change it for that. Now, some people say that KR20 is more accurate, but this is the one that people use, so this is the one that we need to be familiar with. Okay, there's a lot more in this one, but it's really not as hard as it looks. Okay? K over K minus 1, remember?
Number of items.
Number of items. How many items are in this test?
20.
20, yes, we're all the way over to 20, over there. Okay, so 20 over 20 minus 1, 20 over 19. That part's easy, yes? Yes. 1, also easy. Yeah, that's kind of scary looking. Okay. So we've got the population variance and the sum of the population of the item variance. It's all very complicated, which is why it's written here. Now, one of the reasons I've given you the workbook is so you can look at what these numbers are. Okay. So, Cronbach alpha. Can we see the formula here on B109? B109. Can we select B109? Okay. So I've got the easy part here. Okay, and then we've got B108. What's B108? Well, that's 1 minus B108, that's this part here. B108, there it is. What's this? What's this? Well, it's the sum of these numbers. the item variance. Okay. So let's have a look at these numbers. Okay, so what we've done is we've looked at the, when we make standard deviation, we look at the variance of all the numbers, like all the difference, the way they are from the mean. Okay? And we've calculated the sum of those numbers here. So the variation score that we get here is 0.25. Okay? And then we've got a list of them. This is the variation on all the items. So the sum of the item variation is there. That's this, plus this, plus this, plus this. Okay? That's the variation. Okay, the next part of the formula is 104. W104. Where's W104? That's the variation of the population. Okay, which is the total score. Okay, these numbers, it's the score. It's the score. Okay. Then we've moved this formula for Cronbach alpha into this square here. Okay. So the first part here, k minus 1, that's here. Then we've got the sum of the variance up here. Okay, and the last part is over there, W104. Okay, this formula and the translation of it is taken from this book. Okay? There's another way to look at it in this book here. This is a sort of the older book. This is for people who are good at just reading and following instructions. This has a CD in the back with files and videos. And there are instructions in the text. So you can listen, you can read, and you can follow the files going through. Okay, so I find this one much more useful than this one. Okay, but this is still really good. Okay.
Can I ask a question?
Sure.
Here it says SI2.
SI2, yeah.
And here it says SI2.
Mm-hmm.
But here it says population, here it says item. I'm confused.
Okay. This is very confusing.
No, because...
Yeah, so I'm...
Checking?
Yeah, I'm checking in that. So, the formula that I have here is taken from here. The formula that I got is taken from here. It's basically a scan sheet. Okay, and the instructions, I've always followed this book.
I just think that the under K, the S1 squared should be item variance. The label should be item variance.
For each item.
Yeah. I think population is the wrong word. I think this should be item variance because it's this.
That would make more sense, wouldn't it? Yeah.
Population variance is here.
Right.
The population variance of each item. So,
Sure.
this one.
Yeah, I know, that's item variance.
And we have bar P. That P stands for population. So we are estimating population variance.
For the
That's,
items.
yeah, that's what it is.
Oh, okay, maybe that should say the population variance for the items.
Yeah.
Yes.
Sorry, I was
Yeah.
confused when I looked at that.
On Excel, there are several different kinds of variants. There's var A. If you get stuck with Excel at any stage, what they all say to do is to click on the function bar and use a search here. Okay, and if you put in English, is that not changing to English? Yeah, if I put in var and do a search, we got var P, var S, and var A, etc. It's all very confusing, which is why I quite often refer to the books formula. So that's why the var P, that's where the var P comes from here.
Okay.
So it's the population variance for the items,
Each
for each item, yes. Okay. Right, so the alpha that we get here is 0.81. Okay, 81275 probably goes on. It's a good idea to shorten it down. Usually 2 decimal places is enough. Okay. How are we doing for time? Would people prefer to try an example of this? Or would you like to look at another method of doing the reliability? Would you like to look at KR21? A lot of this is quite simple if you just plug in the numbers and you have the formula, which is why I've got the sheets here for you to have the formula you can look at later on. Would people prefer to look at KR21 or spend a bit more time on this one? This one? This one.
Yeah, this one is important.
Yeah, it is. Okay. Okay. Actually, you know, this might be a good time to look at your website. Yeah? Right, let's do that. If people can open a new window, you can hit this little plus button. Okay, down the bottom there's the classical test theory button. All right. Schedule's finished. Okay. So what we have here is a really simple way to copy and paste all of your data and get lots of the information that we've already talked about all together in one place. Okay? And for some of you, that this is probably easier than calculating things. Okay? So what we can do is we can take a quiz and we can drop it straight in here. This is an example from okay, from the textbook. Okay. It's a 20-item test also. Okay, and there's a key at the bottom. So what I could do with some of the earlier data is I could take things like this and copy and paste them directly in. Okay, so
Is that the first column?
yeah,
Is that
without the first column, sorry, without the first column. Okay. My answer key at the bottom there. Okay, then I can copy in an answer key. It's better to copy in an answer key. Hand typing doesn't work. And then it will give us all the basic statistics that we want. Okay. So you've got the binary data at the bottom. Okay, I'm going to refresh that so it's back in the old same page as everybody else. Okay, so the alpha here is 8.13. Same process, exact same process, automated right here. Okay. There's a lot of data on here. There's a lot of data on here. Let's go back and look at some of it. One important thing we can look at here is performance on each item. This is item discrimination for each individual item. How many people chose A? How many people chose B? How many people chose C? Okay, the correct answer is D. This item's doing okay. 23 of the top performing group got it. 16.8, that's a good pattern. Okay, C, we can see the same thing. We can also see how many people are choosing the other answers. So, lots of the lower level students are choosing A and B. Okay, and it might be worth us going back and saying, well, why? What is it about A and B that's working? What's getting them confused? And we go through and see the performance on each item here. We have a histogram. Very useful for sharing data with other people. Okay, box plot. Okay, standard deviations displayed in red. Okay, the main number we're concerned with is the alpha coefficient. So, let's go and take a practice. Okay, at the bottom of the page, at the bottom of the web page for the reliability, so on the website, you're all on page 4, reliability measures and other calculations. If we go down the bottom, we'll be able to see a page marked extension activities. Extension activities. Click, yes please. Oh, rat bags. Sorry, the file I had doesn't seem to be there. Give me a small moment. In the introduction to the workshop, I suggested that people may like to bring data with them. If you did bring data with you, okay, you might want to see if you can put it into one of the worksheets we brought. I will get you some data in about 2 minutes. If you don't have data already, I'll get you some in about 2 minutes. Actually, Atsushi, do you want to talk any more about the website, pages on that website while I do that? Okay. Okay. Sorry, the website doesn't seem to be working. One of the documents is missing. So if you brought data, please check. No data? No homework? Okay. If you're on the extension activities page now, and you click refresh, at the bottom there is a file. Yep, practice. Okay, this is binary data. It's only right and wrong. That's all we need to get the average. Okay, so we can take the first column. And copy. First column of items. Press Control Shift, we can get that first column. If we then press the right key, we've selected all the items. Yes? We want to copy these items and transfer them onto the website. So B1, Control Shift together and down. So that'll take you down to number 25, Jane Phillips. Okay. And then on your keyboard, you have an arrow key. So still holding Control and Shift. Still holding Control and Shift.
Do I first have to get rid of like question 1, 2, 3?
Sorry?
Do I have to get rid of the first one? Surname and question 1?
Yeah, so we highlighted from column B. We can copy that. Okay. I'll run through this one more time in a minute. Okay, next, to paste in, we need to select all the data and change it. Okay, so Control A. Click anywhere on this data and press Control and A, which is select all. Control A. Yeah. This is a bit fiddly. Command key for a Mac still works. Okay, Control V. We'll put all the data in. Bottom up. You should know. Okay, let me write this up here so it's easier to follow. Okay, so cell B1, Control, Shift, plus the arrow down. Okay? So on square B1, B1, Control, Shift, and down. Okay. Next, Control, Shift, and
Arrow.
the arrow key.
That's cool.
Okay, you should have selected all that. Okay. You can either then use your mouse or the keyboard shortcut, Control and C, to copy. Okay, Control and C. If you're working a lot with Excel, you need keyboard shortcuts. Can't use your mouse. Really can't use your mouse. Okay. So now you can see I've got all this copied. Control and C. Okay. Now back to the website. You might have to refresh it. Okay, the button at the top. That little thing. So refresh. If we press Control A, now that selects everything. Control plus A. Okay, and then Control V. And that's all in. Okay? We've got these numbers. Okay?
We have to change the answer keys.
Yes, we do. Yes, we do.
Is it okay?
Okay, so now we need to change the answer key. To do that, we'll go back. And we'll just write 1, 1, 1, 1, 1 under everything. Okay, that means everything is correct. Okay, and we can select all those ones. Control, Shift, and select. So row 26, we want to go from B26 to Z26, all ones. Okay. Control, Shift, and arrow key, you can select them all. Then again, Control C, copies. Oops. Line test JP. The answer key. Control A on the answer key. And B, there we go. I was thinking this would be faster than doing Excel, but maybe not. I was trying to save time, I do apologize. Okay, so to get the answer key, we'll work on the answer key now, yes? If you've managed to get the answer key, can you put your name card up, please? If the answer key is okay, put your name card on top. Okay, and maybe you can help out some people who haven't. So one more time to get the answer key. So to make the answer key, one more time, go to row B26 or 27. B, choose your row. Maybe B26. Okay, and press 1, 1, 1. We're going to make everything 1. 0 is wrong, 1 is right. So for our answer key, we just want a list of 1s. Okay. So, select all those, Control and C for copy. Okay? You've done it? Excellent. So you're ahead of things now. Okay. Copy. Go into the website. Okay, and the answer key, you should end up with this. Looking good? Yes. Okay. Now, this test, this is a real test. This was given to my students at a new school. It was a placement test by a well-known publisher. And its purpose was to show people's general level at A1 or A2 and CEFR. Okay, the classes that I teach are not, or were not, graded by ability. They were just student numbers all together. Okay, so I thought, I wonder what my student abilities are all like. So I gave them this placement test. My question to you is, was it a reliable test? Was it a reliable test? Take a look, what do you think? What do you think? What have we got for our alpha? What's our alpha?
1279.
Yeah, this is a well-known publishing company. Yeah, this is real data. This is real data. How many of us are giving placement tests from textbooks? You might want to check that.
It's not bad.
Okay, are there any items that are working? Are there any good items there? Can you see any good item discrimination? You can either use the website or the Excel. So things we want to look at on this test. Yeah, that alpha is really horrible. Okay, if we look at the list underneath, we can see the reliability if an item is dropped, okay? Or what the raw alpha is. High is good. The raw alpha, high is good. Low is bad.
So question 7 is okay.
Yeah, question 7 is good. Question 21 is kind of okay, yeah. Question 10 is not giving us any help at all. Question 9 as well. These are not good items. Let's have a look at how they performed. Question 9 and question 10. Not good. Yeah, most people are choosing the wrong answer. Same for question 10. So Ray, you said question 7 was a little better?
0.372. Question 4
Yeah.
is good.
Which one?
4.382.
Question 4. Well, question 4 is better, isn't it? We can see that in the items. Okay, if we look at the individual responses, you can see question 4 is a little better than most of the others. Question 5 looks reasonable as well.
Question 4. The right answer is 1.
Mm-hmm.
And you got lower students and middle students beating the upper students.
Yeah, that's a problem, isn't it?
Definitely. Well,
More people are getting it right.
the lower students are getting it right.
Yeah. The middle students are getting question 5 right. That's a bit odd. There's question 7. Only one of the upper level students got it right. Question 9 and 10 we're getting
8 is terrible. 7 middle got it right and only 4 upper.
I ended up totally ignoring this test. Okay, so we've got a low alpha, we've got poorly performing items. This test is not a useful test. Okay, I think the test that was in the original it functions much better. Yes, you've got the 0.83. If you compare this test to the other test, you can start to see how items perform differently. Okay, and what good things look like. Now, there is one more measure that is important. Sorry?
Every data says it's error.
Okay.
It says
You
error.
also change it.
Yeah, we're up 4:15, so I want to move on a little bit. I'm hoping to have a break in a few minutes, but maybe I can come and show you then. Okay. All right. The last thing I want to look at is on the reliability worksheet. Last thing on the reliability worksheet. Something called SEM. SEM, the standard error of measurement. Okay, you remember my story about the scales? Getting on the scales and finding a 4 kilo difference? That's a big difference. Now, every test, particularly language tests, every test has some degree of error associated with it. TOEIC has an error of about 35 points. About 35 points. So if your student gets 500 points on TOEIC, that means their true ability is probably not that 500. It's going to be higher or lower. And there's a 68% likelihood of it being within 35 points. Remember that bell curve? One standard deviation is basically about 35% either side. Okay. So if your student takes TOEIC today, gets 500 points, and gets 530 points next week, maybe there's no change. Okay. It could be they got really lucky this week, they got 530, and next week they take it and they get 470. Maybe their real measure was 500 and they just got lucky and unlucky. That can happen. That can happen. For tests like TOEIC, we need to see a much bigger change. If they take it several times and it's trending upwards, well, that's something we can say. But 2 different tests, we have this error of measurement, and there's a way to calculate it listed here. It's actually quite simple. It's at the bottom of the JLT reliability worksheet. And it's the standard deviation of the test multiplied by the square root of 1 minus the reliability of the test. That's a big long formula. That's a big long formula. Okay, it's actually one of the simpler ones, but okay, if we know the standard deviation of the test, which we do, we've got it over here. Standard deviation is here. Okay, we multiply that by the square root of 1 minus the reliability. Okay, for the reliability we had 0.81. That's going to give us an error of about 1.96. 1.96, 2 points. Call it 2 points. So that means that any score that we see here is going to be plus or minus 2 points, roughly. Now there's only 25 items here. And if we've got that bell curve and it's tight, it's going to cause a lot of problems. That's why we want a lower curve if we're looking at a good sample of the population. If we want to separate out the population well, we want a wide curve. A wide bell curve. Okay? This is well worth calculating. Is it on line test? Standard deviation? On the page we were just looking at? It's on a different page. Okay, it's on line test on a different page. Okay, I think brains are quite full. Let's take 5 minutes. Okay, before we go for the last push, when I'll be explaining about some alternatives to these kind of approaches. Okay? There is an Excel sheet, but I think I'll drive this time. Okay. All right, let's take 5. Come back at just after 25 past. Okay. Thank you for sticking with me. We've had differing levels of success with the Excel sheets. Please take the Excel sheets home and play with them. I've also left outlines on the website that you can go through and review. I've tried to keep the website language non-technical. Okay? If I've succeeded, well, you have to judge that for yourself. I can strongly recommend for classical test theory, if you're going to get one book and one book only, then go for this one. Okay, go for this one. Because it's got the videos, it's got the files, it's got the data for you to play with. This also has a section on criterion reference testing as well, and it deals with the practicalities of testing, the validity side of things, not just the numbers. Okay, today we've been focusing mostly on the numbers. Okay. So, I'm going to talk about alternatives to classical test theory. Mostly, that's item response theory. Okay, these days. Item response theory has had a major impact on testing over the last few decades. ETS, the people who make TOEIC and TOEFL, use it extensively. There is an American group of psychometricians who will use this. We just had the meeting of the Pacific Rim Measurement Symposium who used this in Fukuoka 2 weeks ago. So it's quite a powerful tool. I'm going to try and introduce it to you in simple language. Lots of the books are very mathematical. There is a book wandering around here that will help you, that applying the Rasch model, which is by Trevor Bond. 3rd edition was released in, I think, April or May. It was fairly recent. I think we have 2 Chinese participants. There is a Chinese edition of the book available. A Japanese version of the book is being discussed. Whether it succeeds or not, I don't know, but it's being discussed, is the news I have. So, the main problems that classical test theory has is it relies a lot on bell curves. And we get things like standard error of measurement, which is 2 points, but it's 2 points at the top level and it's 2 points at the bottom. And it's 2 points in the middle. It's 2 points everywhere. The standard error of measurement is very uniform throughout the test taker's profile. That's clearly not going to be the case. You're going to get more error on the margins. You're going to find more people who've been luckier or unluckier. The other thing is that a lot of the scales that people create, they're not uniform. If I'm giving people a 10-item test, the difference between people who score 5 and people who score 6 may not be the same as people who score 7 and 8. That 1 point difference may be totally, it may not be the same increment. That's why I mentioned earlier about Stephen's idea of scales. A lot of the tests that we give end up being nominal, ordinal. They're just like running races. Okay. The other thing is that there's a tendency to focus on the items only, on the piece of paper. It doesn't really look at the people who take the test. The qualitative aspect of test validity is often underrated. The numbers will take you so far, but you need to look at how people behave as well. IRT and RASH takes time. It takes a way of thinking about numbers, which is not, well, it takes a while to develop. It takes a lot of effort to develop it. That said, it's much easier than it used to be. There's a lot more accessible texts out there. Okay, so I'm going to try and introduce it. A lot of the core concepts are quite similar. So I hope that if you're starting to get the hang of some of this, you'll be able to get the hang of IRT or RASH theory. So I'm going to try to cover in 15 minutes first thing on item scoring, item information curves, and infit and outfit. Okay. How many of you have heard of these terms? Let's see. Item information curves. Have we heard of those? Quick show of hands. Okay. Infit and outfit. Have we heard of these? Okay. Right. Let's see how we do. The main software that this is run on is something called WinSteps. Okay. It's quite technical at first. You need to learn how to program simply. Once you're past that, it gets a lot simpler. Okay. Now, imagine we have a test. Okay. It's an amazing 3-item test, and we have 3 people taking it. Okay. What RASH analysis will do is it will take the data from the people and match it with the items and kind of go through it many, many times and try to create a pattern. Okay, and it will try to create a scale, which we call a logit scale. Okay, logit scale. This uses natural logarithms. Okay, and a logit is a logarithmic unit. Log, it, logit. That's how you get the name. So, in the RASH model and the IRT way of thinking, the person 1 and item 1, they're at the same point on the scale. Okay? And there's a probability measure of getting this right. So if person 1 has an item that has a logic 1 skill and meets an item 1 which has the same level, they have a 50% chance of getting that right. Okay, and the distance between item 1 and item 2, which is on 0, this is the same space as the difference between item 3. Okay, and there's a fixed chance of getting these items right. Similarly, the items meet people, which is something maybe not immediately intuitive, but items meet people. And they work on the same scale. So person 3 has a 50% chance here, okay, of getting this item right. Person 1 has an 88% chance of getting it right. They may not, they may slip. It may be the one area that they're not familiar with that comes up. Okay, so we create this scale, this logit scale. Okay. Anything you can do with a person, you can do with an item. Anything you can do with an item, you can do with a person. The mathematics works both ways. Okay. And this translates into something which is called a bond diagram here. Trevor Bond wrote the book, which is probably most popular. This is the book. Okay. And we can see the scale here. We've got +1, +2, +3. Okay. At the bottom here, we've got Mike. Mike has the lowest ability level. That's about 0.25 logits. Okay. Now, he may well have got item L wrong or right, but it was about a 50% chance. It's pretty close. Didn't do very well on these items. These items are way up here. Okay. Now, who's the best person in the class? Who's the best person? Okay. Who probably got the highest score? Well, Bill. Bill. Okay. Bill still probably got item U wrong. Item U is a hard one. Okay. Now, we've got a path coming down the middle. We've got two grey parts here. Okay, two grey parts. Beth's ability seems to be a little better than Bob's, a little less than Bill's. Should be around these items, but her behavior is erratic. She got some easy items wrong, but she got some difficult items right. So there's something about this test which is not fitting Betty's behavior pattern. She's an outlier. Okay, and that's outfit. Outfit. Item W. Item W is behaving almost perfectly. All the high-level people are getting it right. All the low-level people are getting it wrong, and that's just a little too perfect. If things are too perfect, sometimes that's a problem. Okay? Okay. So, at the conference tomorrow, you'll probably see that diagram looking more like this. Okay, this is the output from the software that I talked about earlier. We've got the items over here. Okay, you can usually see the numbers. You've got people here. On most output, an X is 3 people. Okay, there's a. Can you see any dots here? I think I may have covered it. If you see a dot, that's one person. Like a full stop, that's one person. Okay, so we've got people on one side, skills on the other. This is a test. This is a test of children's ability on a Piaget scale. Okay, so it's a developmental test. Okay. The other thing we get when we look at this is we get something called an item information curve. Okay. So here we've got the 0, here we've got the 1. This is that zeros and ones that people really, really like. Okay, pass, fail. At the bottom you've got a logit score. So a person with an ability of -3 has got less than a 0.1 chance of passing this item. It's probably not 0, because they might be able to guess. Trevor, are you presenting on guessing?
Yeah.
This session's interesting presentation probably on guessing behavior with students, worth a look. I think it's particularly with reference to IRT, isn't it? So yeah, worth a look. Okay. This goes up as the logit score goes up, the probability of getting it right goes up. So a person of 0 ability, that's slap bang in the middle. Okay, they've got a 0.5 chance. And then people with high ability, they'll probably get that right. But in the 3s, they're probably going to get that right. What we can do is we can take a series of questions of different difficulties. This question, this is quite easy. A person with a 0 level ability, they've got a 0.7 chance of getting that right. Okay? But this question is more difficult. This is aimed more at this area, people who are good over here. Okay? So with item response theory, what we're looking to do, the Rush model, is set up a series of questions that have got a good slicing action. Okay, and we're going to try and finely cut using this measure. Okay, I don't have a lot of time to go into how it works, but a really nice test would look something like this. Okay. Then we have the fit statistics. The fit statistics. Okay, in fit and out fit. So in fit is the degree to which it follows the model. Out fit is the degree to which you get erratic behavior. Okay, behavior that doesn't fit the pattern. Okay, now both of these have an MSQ score, mean square score. Okay, the baseline for that score is 1.0. Okay, yes. What's a good score? A bit like reliability, it changes a little bit. This is used for a lot of purposes. So for surveys, the scores will be different from testing. And for developmental testing, it might not be the same as for language testing. But as a rule of thumb, for language testing, anything that's above 1.3 on these scores, that's not so good. Okay, this is very, very rough. Okay, anything below 0.7, it's probably a little too good to be true, so it might be worth another look to see why it's behaving like that. Okay, so those are presented in a way that you'll see on the websites. Let's see, Rush, I can do Rush model. We'll get in-fit and out-fit on both items and people. Whatever you do with an item, you have to do with people. Whatever you do with people, you have to do with items. So the in-fit scores and out-fit scores kind of replace reliability to some extent. Okay? Getting any data on from the test? Okay, I have it on Excel. I have this on Excel. So, oh, there we go. There we go. Okay, so down here we've got a estimation of how difficult the items are expressed in that scale. Expressed in that scale. Okay, so usually it's kind of -3 to +3. You might get somewhere around just nearing 4, but it's usually around there. So we can see that question 13. It's a very easy item, very low score. Okay, let's see. Question 20 is getting hard. Question 20 is getting hard. It's got a higher score. Question 32 may well be the most difficult item here. 2.78. That's hard. That's really hard. Okay. Here I've got people. This is a theta score. This is a person score. Person score. So person 3, they're quite good. They're quite good. Got a score of over 1. Person 4, good. Well, these are all quite good, aren't they? Person 24, somebody's not quite as good as the others there. Okay. So I can predict that when, for example, person 6 means item 13 and a really low score, that was like -3, I'm probably going to get that right. Okay. I can also tell you that person 15 is less likely to get that item right. They still got a good chance, but they can be measured on a scale. You can see how much more probability they have of getting that item correct. Okay. Now it's 10 to 5. Oh, item fit. There we go. So this is the mean square score. Question 2, a little bit of a problem now. Might want to have a look at that. That's 1.4. That's a little high. Most of these are that's a little low. The low is not that big a problem, is it? It's kind of okay, but I might want another look. Okay, outfit and infit. The T-score here. The T-score here. This one norms at 0. Okay, and anything over 2 or less than -2 needs another look. Okay, so we've got 4 characters here. One of these is about the data you actually have, and one of them is about the probability of that data actually happening. Okay, so it's kind of a comparison. The software that comes with it, WinSteps, provides lots of diagrams, which is very helpful when talking about discussion. If you're talking at a classroom level or with colleagues, for most of the time a histogram is probably going to be okay. You're probably going to be able to read the shape of the distribution in your class. But when we're getting into higher stakes testing, like making TOEIC items or end of year exams for the whole year, we probably want to be looking at more precise tools like this, where we can say that there is an actual scale that matches, where people and items can be put together. And we can see a very clear developmental scale. Okay. Is that probably enough for the rational, I think?
Yeah, show some diagrams.
So diagrams at the bottom, okay. While that's taking its time to come up, I want to tell you one more thing on the website. At the top of any of the pages you've clicked on today is a bibliography, okay, a reference list. I've put some general texts on testing procedures. This is the whole of testing. Classroom testing, principles, validity, the full discussion. There's a few of them I brought with me today. There's one there, one here. Okay. Test analysis. I've got the two books that are here referenced, and there's also a much simpler short article by Elvin from the language teacher. Okay. Test specifications. We talked a little bit about the TOEIC items and making tests. Testcraft is a little bit of an old book now. It's 2002, but it's gold. It's a really good, easy book to read. The thing I like about it most is that it really focuses on the teamwork that's necessary in making items, okay? And reviewing items. Using numbers like the numbers that we get today and saying, we've got this data, we've got the item, shouldn't we be changing the way we design things? Okay. Bond and Fox, I've referenced the new edition. I've put a link to some Japanese books that were recommended by Kimura Sensei, who uses the rash modeling for computer adaptive testing. Okay. And finally, there's a link on research and other software and resources. Of particular interest is probably the R project. R is incredibly useful. Again, it has a bit of a learning curve, but there are some tools that will help you to do that. Okay. All right, let's go back and see if Rash has finished its job. Yes, there we go. Okay. Here we've got a person item map, which is similar to what you saw before. We've got the people up here. We've got the items up here. Okay, and we can track these people down here. Probably got these items right, but more likely to get these items wrong. Okay. Oh, sorry, other way around. These are the easy ones, right? Yes. -3, that's okay. -3, that one's going to be okay. Middle items. Question 41, question 42, we're heading to about the 0 logit scale, mid-level of ability there. Okay. This is what happens when you put all the item characteristic curves together on one map. If you get the full software of 1 steps, you can examine each curve and you can start to put them together a little more clearly. But we can see the outliers fairly clearly here. You see we've got a good curve ability. More difficult questions. Sorry, easier questions up here. We've got about 5 minutes left. Do you want to say anything more about websites?
Yeah, as for IoT or Rash analysis, you have to know how to use software first. And maybe if you're a Mac user, you cannot install WinSteps right, in the first place. So this type should be really helpful. You can just put your data there and then you can see the results. And with that Bond and Fox curve, you can compare the results and you get to know how to use Rash analysis.
The Bond and Fox book has a data set that you can use and play with. No. The other software that I mentioned earlier, JLTA, is it? Yeah, that does seem to allow you to do it.
Yeah, if you're going to do serious Rash analysis, you need to use either WinSteps or Facets or Run, like the specialized software that does a much better job. But there's also a program called Conquest, which was made in Australia, That's very powerful. It's quite difficult to use. WinSteps is the most user-friendly, but that's Windows only, so that puts a lot of people off. WinSteps is the easiest one to learn.
So WinSteps is it still $99? Something like that?
It's 149.
149.
Yeah. But if you buy the modern Fox book, it has a usable version. But you know, $149 is pretty cheap for your software.
And it's good, powerful software. Yeah. The data in here is usable. It's got a lot of the functionality blanked out, but in a way for beginners that's much easier, because if you look at the full program when you're just starting out, there's so much there. It's frightening.
May I ask a question?
Sure.
About the item characteristic curves on the slide. It looks like to me it's a kind of 3 parameters model. Because of as far as I understood, the last model is the 1 parameter model. It means that it should be from 0 to 1. But that one looks like 3 parameters model. Only just a cut off the tail. Yeah, that's right.
Is it a 3-parameter model or?
No, this is 1 parameter model.
It's just cutting off
the curves are not
of the edge of the right side.
This is from 0 to 1, and then this is the
Only just a range, from 0 to -4. It should be the long tail
Yeah.
of the high item.
So one thing is people like Mike Lineker don't like calling Rash IRT model because it kind of has a different underlying theory. So there's a lot of arguments about that. This is the theoretical ideal of what the item should be doing. But as you say, in reality, they won't follow that pattern. So,
Okay, thank you.
There is a very, very easy version explaining how the logic scale works in Excel that you can pull off the website. Okay, I hope it's easy. There's also a more complex version of it linked in the references. So I tried to make a very easy version of it and put it on there. So, okay. Anything more? Any final questions? Apart from my student. Okay, thank you very much.